Postgres works great up to a certain scale, and then it stops working. And so what you find is that users have the option either to like try to get like a very niche database, move off Postgres, go to something they're less familiar with, their team's less familiar with, there's not as good enough ecosystem for it, or they could just, adopt Timescale and basically keep everything they already know and love and then get these kind of superpowers on top of it.
When you have compression, you do not calculate the uncompressed storage, if I understood that correctly, but you're calculating the actual storage uses. So if I have like a 90% compression ratio, that means I'm paying like for 10% of the actual data stored.
More broadly, I think we are bullish on Postgres. And what that means is that, we think that 99% of developers' problems can be solved with Postgres for a database. Now, there's going to be always that 1%. There's going to be the, hey, I'm building Netflix, Uber, Google. They're going to build custom. But that's not what most companies do.
Hello, everyone. Welcome back to the next episode of Simplyblock's Cloud Commute podcast. This week, I have a very special guest. I know I always say I have a special guest, but this week it's actually a special guest because he's basically my old boss. I used to work for him. We know each other for a long time, and nobody knows why. That's the best thing about it. But maybe Mike had some idea by now how to get here. So, hey, Mike. Welcome to the show. Glad to have you. Maybe you can give a quick introduction of yourself.
Sure. Thanks for having me, Chris. Mike Freedman, I'm the co-founder and CTO here at Timescale. Timescale is a database company we build on top of Postgres to make it powerful for time series, advanced analytics, AI, and other things. I've been working in distributed systems and storage systems for many years. Not only as a founder and engineer, but I'm also an academic. I'm a professor of computer science at Princeton, where I've been on the faculty for the last 17 years now. So time flies a little bit.
Oh, wow. 17. I knew you were at Princeton, but I didn't know you're a professor for that long. Wow. All right.
I have a bunch of stuff with elbow pads and gray beard, that's perhaps my other persona.
Okay, I see. All right, you already mentioned Timescale. You said it's a database on top of Postgres. Maybe you can elaborate a little bit more on that. A lot of people listening in are actually Timescale Postgres users, probably Timescale as well.
Sure. So Postgres, old has been a database for now. Since the 90s, been very popular, but really I think found a renaissance in the last 5 years. Is, according to like Stack Overflow, is now the most popular database in the market. And I think when people today look for something, that's what they turn to. About 15 years ago, Postgres started introducing an extension framework. And so this is what allows people to think of Postgres not only as the features it offers itself, the traditional OLTP database, back your website, e-commerce site, whatever, but also a way that it could be extended by third parties who actually have hooks throughout the database to make changes. In the beginning, that was, add an index, add more monitoring, more smaller things. But Timescale really, I think, is at the forefront of advancing what you could do on top of this data platform other than what is offered by the core infrastructure. And so we basically built it to be also an analytics powerhouse to deal with time series data, event data, anything where rather than very small, like update, deletes, records, you want to ingest as large amounts of data and then ask questions about your particularly almost how your data changes over time, aggregations on top of it, basically insights to drive things like real-time dashboards, API, power customer-facing APIs, and other things like that.
Right. You already mentioned like analytics, data, time series. Maybe you can explain a little bit. I mean, I know what it is, but there's probably still a lot of people that have not really an idea what a time series is and how to identify one.
Sure. So we think of time series as almost any data that has a timestamp where you might actually care about how something over time. And so that could be on real wall clock time. How did something differ day to day? It could also be in terms of some abstract notion of system time. For example, we have a lot of crypto companies that use us for blockchain analytics, where the time that they think about is actually the blockchain height, which is almost a monotonic counter, as opposed to something that corresponds to wall clock time. But the nature of data is that it's append mostly. You are often interested in what happened recently, not randomly what happened 5 years ago, but you also want to often analyze the stuff over it. So rather than simple
Mhm.
point queries, which you currently certainly can do with Timescale, you're often interested in things that look more scan-like, where you want to scan over either some period of time or by other thing like a device, in a game, in a gaming application, a particular user, a session ID, anything that actually has that type of access as well.
Right. And from a use case perspective, that is often observability data in like the infrastructure world. It is any kind of, you hinted at that, like IoT data, like device information, temperature, humidity, whatever. But it can basically be it can basically be everything, anything that has like a time relation, I think.
Yeah, and
That's
we
how I always explain it.
we like to almost say all data is time series, because as you start squinting at it, I mean, I mentioned the traditional OLTP, which is your e-commerce app. Well, if you
Right.
actually look at that database, where over time, if your business is successful, where is most of your data going to be stored? It's something like your orders table, which is keeping a record of not just every SKU, not just every item you have, but how frequently you sold that. Well, what is an orders table? Well, an orders table is basically a log of events with a timestamp, and you might look at over the time and see how your sales has changed across a time, across a particular order, across a region. This is all what we think of as time series or event data. And so, yes, so you might think of it as there's certainly been use cases in observability, but in IoT, in manufacturing, in energy, in gaming, in product analytics, in music analytics, anything where you ever would build a dashboard on top of your data, I think is a good, or analysis over your data, I think is a good use for something like Timescale.
Yeah, I agree, and I like the like order invoice table kind of stuff, because that is something people really do not consider as time series. But as you said, when you want to build a dashboard on top of that, it makes total sense. You want to understand like what is the average order value, what is like the lifetime value of a customer, the average lifetime value of a customer, all that kind of stuff, and hopefully your business is successful enough that this table grows quite a bit. If not,
Right.
you're probably in the wrong business.
Right. And if you even think of the questions you ask, in your, if you have a website or web, console that you have your users log into, typically you'll show them their orders in chronologic order, chronologic reverse order,
Right.
right? Which is, again, the recent stuff gets shown more frequently. Or you might allow them to define, tell me all the orders I placed during this month. Again, it's have your history of all data, but it narrows into particular user or a particular time range. That is the type of things where the type of capabilities we build the infrastructure in Timescale maps very well to efficient, scalable, performant queries.
So the next question would be like, why do this in an extension? I mean, Postgres gives me basically everything I need to do that. And in the worst case, I can partition data, but why would I do that with an extension?
Yeah, so the way I like to think of it is what Timescale has often done is has made Postgres's performance scale for particular use cases. And it is true that, like, obviously SQL is super powerful and Postgres is super powerful. You could represent this problem in Postgres. In fact, the biggest source of users of Timescale is for people who started on Postgres and realized that they need something else to take it to the next level, either because of scalability, performance, cost effectiveness, or we enable a lot ease of use because of kind of the additional functionality we build on top of that. Um, you know, in general, why do we ever have many databases? Is because what you could do under the covers is you build data structures, optimizations, uh, other things that basically make it both easier and more performant to manage. I could talk about, various technological things that we built, but that's basically the reason. It Postgres works great up to a certain scale, and then it stops working. And so what you find is that users have the option either to try to get a very niche database, move off Postgres, go to something they're less familiar with, their team's less familiar with, there's not as good enough ecosystem for it, or they could just adopt Timescale and basically keep everything they already know and love, and then get these kind of superpowers on top of it.
Right. So you mentioned superpowers. Maybe just give one or two examples, because I know there's super cool features.
Sure. So stop talking black magic and give the engineers something to sink their teeth into. So one of the really interesting things is that Timescale has a very, what I'd call, interesting data lifecycle. And let me get into it. You mentioned briefly before partitioning. Timescale has these things which we call hypertables rather than tables. And one of the big differences is they basically do automated partitioning under the covers. You kind of create a policy. You might say what roughly is a time period which you want to partition the data. It could be a week, it could be a day. We have really high-end services that do it every 10 minutes. And you just set it and forget it, and it could be modified over time and adapt as your data volume scale. But under the covers, what we're doing in a bunch of things, but one thing I want to talk about with data lifecycle is we basically kind of change the formatting of your data as it ages, because your needs will often change. So for the most recent data, we store that in row-based form, and that becomes much more efficient than to do high ingest rates, because usually data comes in as an individual row, and you can kind of insert it row after row after row after row. And then as it gets a little bit older, we basically have the engine underneath the covers would automatically change it to a compressed columnar format. And so compression is great for cost savings. In production, we see on average something like 90 to 95% storage reduction once people adopt our columnar. We actually use different algorithms per column based on the data type automatically. And then columnar means that I talked about scans before. It becomes much more efficient then to do kind of longer queries over time, particularly when you're interested in primary keys, where you want to scan over the user, or when you want to ask questions about certain columns as opposed to all the columns, let's say, that might be in the database. And then even third, on our cloud, we offer a tiered storage now, which is when we actually store the data from, it starts in high performance row format to high performance columnar format, and now to tiered warm storage. So this is kind of tiering it off to S3. So it becomes this bottomless store for data that, again, is transparently queried, but now provides this trade-off for you as a developer. Your trade-off between the performance you get from it versus the cost of, how expensive the storage is. And again, you create a hypertable, you set two policies for when you want to move something to columnar and when you want to move something to tiered storage, and everything else is handled for you. So there's an example of obviously Postgres itself doesn't have a columnar storage, doesn't do this tiering. There's a lot of query optimizations on top of it, which we use to select which portion of your data we query. We build a lot of small indexes. We build sparse indexes. There's a lot of this fancy stuff under the covers. Again, as a developer, you don't really think about that. Kind of, we've done that for you.
Right. And as a developer, I feel like I want to get started right now. So how would I go about that?
Yeah, so there's two ways. One is Timescale is open source. You could go to GitHub, you could download. We provide different installations that you could use. We also, in our businesses, we build a Timescale Cloud, which is a managed service. And so you log in, go to timescale.com, click one button, and you have a database running up and starting in 2 minutes. That takes I think I would describe our cloud in two ways. One is it obviously takes care of all the operational complexity you normally have from operating Postgres. HA, replicas, backup restore, port in time recovery, upgrades, observability monitoring 24/7, all that stuff. But also it is intentional that we know we're building these type of applications. So not only there are operational improvements, but there are also those like application level improvements. So these things like tiered storage, which you might have, you don't find this in something like RDS or something else. This is really built because we understand our problem domain and build a cloud product for it.
Right, right. And you said you can run it yourself. It's Apache license. Is there anything I need to be careful about? Like how do I deploy that? Do I deploy it into Kubernetes? Does it run on Docker, like virtual machine or whatever?
All of the above. You could, I mean, software you can deploy in many places. We provide Docker images. We provide some RPMs that you could install into your thing. We ourselves use Kubernetes internally, and we know a lot of people
Hmm.
deploy, and we have a Helm chart, but a lot of people deploy it with existing Kubernetes operators, kind of community ones built for Postgres. They work for Timescale as well.
Right. You already hinted you're using Kubernetes internally. So let's switch to that because we're a Kubernetes
Sure.
podcast and a cloud podcast. So um, we can share about the infrastructure without I have to sign an NDA for the whole community.
Sure. Sure. So, we're heavy users of Kubernetes. One of the things this allows us to do is, operate at scale where we have decoupled the problem of spinning up AWS instances, which, often, or other hyperscaler instances, which are often on the order of minutes, from individual placements of containers and whatnot.
Hmm.
Uh, it's been we've been using Kubernetes from the beginning. So I guess now, since our cloud has been almost 5 years since we started building it, uh, have obviously gone through the joys and the trials and tribulations of deploying Kubernetes at scale. One of the big things about Timescale Cloud is that we have decoupled compute and storage. So users can independently size their database and kind of at any time change the sizing. So if you all of a sudden want to move from 2 CPUs to 16 CPUs, it's a click of the button. And that can be done with, in some cases, an HA, no downtime. If you have non-HA with, typically something like 30 seconds of just
Hmm.
replacing a container because it's decoupled from your storage. And then we manage storage as a completely separate tier that grows independently. One of the other interesting things about, again, enabled by Kubernetes, but also a lot of things we do ourselves, is we, normally when you think of databases, you think of hard provisioning your storage. You need to provision a disk. I want to provision 100 gigabytes of storage or a terabyte of storage, as the case may be. Um, on our cloud, we hide all of that complexity from users, and users purely have usage based storage. So, what that means is they never think about allocating storage, they just start storing data with it. It scales
Hmm.
as they need. We manage all of that in the back end, and they pay for only what they use. So, if they're using 496 gigabytes, that's how much they pay for. And if they turn on something like compression and it drops down by half their storage consumption, which is what often happens with our customers, they just pay for half. And so they kind of
Right.
we've made it easier and have allowed our users not to really think about managing those things.
I think you mentioned an important thing, and it was basically one of the questions I would have asked anyways. Like when you have compression, uh, you do not calculate the uncompressed storage, if I understood that correctly. But you're calculating the actual storage uses. So if I have like a 90% compression ratio, that means I'm paying like for 10% of the actual data stored.
Yeah, this is one big way where, in many cases, timescale turns out to be cheaper, and not only more scalable and performant, but can be cheaper than even something like using RDS or Aurora, is because you will charge you for your storage. And so
Right.
maybe on a per gigabyte of storage, we are charging more than RDS Aurora. But if you're only using 1/10 of the size, it obviously translates to savings. Not only, again, operational and operational some improvements. We regularly operate with customer databases who are storing many terabytes of data, and Postgres, has starts getting challenges at that scale.
Mhm.
Not storage on disk and querying it, but the operational size. Try to
Yeah.
take a backup and then restore from try to use PG dump restore on a 10 terabyte disk, and it's not very happy.
Even if you use it in the binary mode, it will yeah, as you said, it's not going to be happy. So you said you're running on Kubernetes and you're hardcore Kubernetes users. So we all know running a database in Kubernetes isn't as easy as it could be. So what do you think is like the biggest issue or the biggest problem right now, running it at scale, making sure its performance is on point? And you think like stuff like noisy neighbor and whatever you can come up with. Well, what you've seen in real world?
Yeah, I think there's a couple things going on. One is we we the some of the OS level performance isolation between instances we actually think works quite well, and we
Mm-hmm.
found that at least at that level, on the compute side, we have not run into it has actually worked out quite well. One of the big things that we don't have is we actually have storage isolation between users. So we've actually seen most of when people run into when people have concerns about noisy neighbors, it often relates to one of two things. One is the fact that some architectures have shared storage backends that doesn't have actually
Right.
good performance isolation between customers. Um, and they don't have the ability to basically manage IOPS and bandwidth on a per customer basis. And that is something that we actually do in the cloud, that we also have the ability to, not only do we have of isolated storage per user storage capacity,
Mm-hmm.
but we actually can provision IOPS and bandwidth on a per tenant basis. And what we naturally do is we actually scale IOPS and bandwidth with your storage capacity. So when you sign up without
Mm-hmm.
doing anything else, we start you on a lower level, and then we scale it as your storage scales itself. But we also have the ability to boost it. So we have this notion, which kind of we internally called IO boost, where we have the ability to kind of max out on a certain customer basis, kind of IOPS and bandwidth. Obviously, it costs some extra to us. We pass on some of that cost to our customers, but that actually allows a user to kind of start nicely and then scale as needed. I think the other thing I would generally say with Kubernetes is you're right in that it some of its early promises are meant for like these stateless tiers of horizontal nodes where you don't actually ever have to think about the instances. They're all independent. And
Mm-hmm.
we've never really thought of it that way. We've in the beginning, we've actually had to heavily invest in writing our own operators to manage a lot of things, because we need to, we don't manage thousands or tens of thousands of databases that look the same. We manage each one that looks independently different and has to be managed separately. And
Right.
the other thing I would say is there's a lot of abstractions in Kubernetes. Let's take an example, stateful sets, where the thesis is that all instances of a stateful set look identical. And that's actually something that we've both had to fight with, and then eventually kind of conclude that it's not right for us, because we actually want to manage even replicas of a database separately. So you could do things like
Mhm.
intelligent staged upgrades, stage rollout, stage resizing, which certain abstractions in stateful sets, which is meant to make all of these things identical, actually aren't well suited for.
Right, right. I think the last one is really interesting because that is something that a lot of people will probably fight in the near far future when more and more databases move to Kubernetes. I didn't think about it because I always considered like the replicas being the same. But you're right. If you want to do like a rolling upgrade or stuff, it's gonna be a little bit more challenging. Anyway, we're pretty much out of time. So one last question. What do
Sure.
you personally think is like the next big thing? What is like upcoming? What is already here but growing? I know the answer, but
Well, let me. Maybe this is the answer you thought, but I'm going to give a back to the future. So, Timescale started by building Timeseries and analytics on top of Postgres, and about a year ago, we
Mhm.
launched our AI product, our vector search product, and kind of open sourced it under the Postgres license just a month ago. A lot of really interesting to do what we call PG Vector Scale, which is scalable vector search, and then PGAI, which is allow you to do AI things like OpenAI, Cohere, Olam embeddings directly in your database. Uh, More broadly, I think we are bullish on Postgres. And what that means is
Mhm.
that, we think that 99% of developers' problems can be solved with Postgres for a database. Now, there's going to be always that 1%. There's going to be the, hey, I'm building Netflix, Uber, Google. They're going to build custom, but that's not what most companies do. And that's both startups
Right.
and actually, we deal with some companies that are 1 month old. We deal with companies that were built in the first industrial revolution, right? So we have the large gamut of companies that we serve. And for many of them, the reliability, usability, the ecosystem of Postgres is so powerful. They
Mhm.
have people who know it, they have people who trust it, they have, if they want to use our managed cloud, if they want it themselves, there's lots of options. And so we're very bullish on that. And we continue to basically think about how we then, like I said, make Postgres powerful for all these different use
Right.
cases where it could serve these type of demanding applications. So kind of expect to see, we started by in time series and analytics. We built an amazing cloud platform for Postgres, and in doing so we built, like I said, a cloud platform for Postgres, not just a cloud platform for time series. And so expect more from that.
All
We're
right.
very
Fair enough. Fair enough. That was not the answer I expected. Everyone else said AI. You kind of made me sad here.
well. AI. I actually, I mean, AI, but maybe I have. Let me get take two on that question then. I think 5 years from now we won't be talking about building AI applications. Okay, we'll be talking about building applications where they will all incorporate AI where it makes sense. And
Right.
so, I think we're going to have a lot of people talk about being AI engineers and whatever. I think this will happen, but I think this will actually recede because this will be another thing in the tool belt of developers where what it means to be a modern developer.
All right. I like that. That's a beautiful last sentence, I guess. So we're out of time. Thank you, Mike, for being here. Thank you for being an awesome guest.
Thanks for having me.
And for and for the audience, thank you for being here. Hope to see you next week. Same place, same time. And thank you very much for being here as well.